Hello everyone, welcome back to my math channel MathLab. In this video I will answer you question number 6 from Pearson Edexcel A-level exam for Pure Math 3. This exam is taken in May-June session year 2024. Paper reference code is WMA13/01. Let me read the statement of this question. Figure 3 shows a sketch of part of the curve with equation y equals to square root of 4x minus 7. The line L shown in figure 3 is the normal to the curve at point P 8, 5. First part, use calculus to show that an equation of L is 5x plus 2y minus 50 equals to 0. This is the equation of the normal line. You have to prove it. To find the equation of the normal line, you should have a gradient for this. Point is given there. We want to find the equation of this line. To find the gradient of this line, you should know the gradient of the tangent line. Tangent line is the line that touches the curve at one point only. If I draw here a tangent line, you could find the gradient of tangent line from here for sure. This is a tangent line and this one is the normal. This line, normal line, is always perpendicular to the tangent line. Got it? If you are able to find the gradient of this line, like gradient of line, tangent line m1, you could find the gradient of the normal line, that is equals to minus 1 over m1. Actually the product of these two gradients is always equals to minus 1. If you want to find the gradient of one line, you should take the negative of the reciprocal of the other one. So this is the formula what we can use here. First of all, you need to find the gradient of the tangent. To find the gradient of the tangent, you have to differentiate this equation. For the first part, y is equals to 4x minus 7 power 1 over 2. We differentiate it with respect to x, dy by dx. We use the power rule. Actually, this is the formula you have to memorize. For example, if there is a function, any function, if you want to apply the power rule, this formula is very effective. You just bring the power here and reduce the power by 1, and then also you multiply by the derivative of the function under the power. It is the rule actually. This is the rule, power rule. First of all, we will bring this power here, so it will be 1 over 2, and then 4x minus 7, we reduce the power by 1, means 1 over 2 minus 1, answer will be minus 1 over 2. So power is minus 1 over 2. Then again, you have to take the derivative of the value under the power. This function again differentiated. Derivative of 4x minus 7 is 4. 4x is 4 and 7 is 0, so it is 4 only. Simplifying, this will give you 2 only. And now you can find the gradient of the tangent line dy by dx by using this equation. 2 over 4x minus 7, you can bring this one down to make it positive, or you can take square root. You know that if you want to find the gradient of the tangent line at this point, value of x is here 8. Substitute this value of x there. You will find the gradient of the tangent line. Let's say it is m1. You plug in the value here. X is 4. 4 multiply 8 is 32. 32 minus 7. Then 2 over 25. Square root of 25 is 5. So it will be 2 over 5. This is the gradient of the tangent line. But we want to find the gradient of the normal. Gradient of the normal. Let's say that is m, and we take always the negative and reciprocal of this one, as I told you earlier. You found this one is 2 over 5, right? Then if you multiply here by negative of reciprocal of this one, 2 over 5 will be equals to, for sure, minus 5 over 2. That's it. You just flip these two values and put negative sign with it. If it is positive, make it negative. If it is minus, and then make it positive. Directly we could find it by just flipping it and taking minus. So it is more easier way. You have to memorize the gradient of the normal, how to find it. Minus 5 over 2. Now you need to find the equation of the normal. Equation of the normal at P. What is that? P is 8 and 5. 8 and 5 is. This is the standard equation of the line. You can use this equation, y minus y1 equals to m into x minus x1. Plug in the values. y1 is, this one is x1 and this one is y1, so it is 5 here, and m is minus 5 over 2 into x minus 8. Let's go back to the question. We want everything on the left hand side, there is nothing on right side, so there is 0. So best thing, you should get rid of the fraction, just multiply this 2 to the left hand side, so it becomes 2y minus 10 is equals to minus 5x plus 40. In the next step, you can move these two values on left hand side. This minus 5x becomes positive 5x, plus 2y is already there, and minus 10 and minus 40 will make it minus 50 equals to 0. This is as required for sure. This is as required. Let me show you this one. We got the result 5x plus 2y minus 50 equals to 0, exactly like that. So first part is done. The region R shown and shaded in figure 3 is bounded by the curve, the x-axis and line L. Use algebraic integration to find the exact area of R. To find the exact area of R, I will divide this region into two parts. Let me show you this one. If you join this line here, this P here, we already have the value of x here. Got it? We have this value. Value of x is 8 here, because this point P is 8 and 5. So this value is 8 and here 5. So x value is here. So we can find the area of this right triangle. For that, you have to find the x-intercept of that normal line. To find the x-intercept of that normal line, you should plug in y0 for the second part. Just put y0 to find the x-intercept of the line, normal line. When y is 0, so it left with 5x plus 0 minus 50 equals to 0. This is 0 and minus 50. Minus 50 goes to the right side, and then you divide by 5. Answer of x will be equals to 50 divided by 5 is 10. So we found this point. This point is 10. It means this one has 8 to 10, base will be 2, and here height is 5. Now you could easily find this area of triangle. Area of this triangle you could find by using this formula, 1 over 2 times base times height. Got it? Plug in the values. 1 over 2 times base is 2 and height is 5. So area of triangle is equals to 5. Hopefully you understand how to find this area. Now the second thing, you have to find the area under the curve. We have formula to find the area under the curve. That formula is given like that. This is very famous formula, you have to memorize. From limit is given from a to b, and here y dx. This is the area under the curve. For that, you should know this point. This point we already have. To find this area under the curve, this part, then you have to use this formula for that. It means this point is there, b is there, but we don't have a. To find this point, you should find the x-intercept of the curve. X-intercept of the curve. This was for line. Now for curve. Y is equals to square root of 4x minus 7. To find the x-intercept, you plug in y0. Y0 implies that 4x minus 7 square root will be equals to 0. Take square of both sides, you get 4x minus 7 equals to 0, and we get the point as x equals to 7 over 4. Got it? So we got this point, x equals to 7 over 4. Let's go back to the figure. This point is 7 over 4. Now you have limit now from 7 over 4 to 8. You will find the area under the curve. To find the total area, you just add this area to this area of triangle. Therefore we can write here the total area of the shaded region will be equals to area under the curve, that is y, this one 4x minus 7 power 1 over 2, and here we have limit 7 over 4 to 8 dx, and plus area of triangle. You have to add that area. because the total area will be this one, area under the curve plus area of triangle will give you the total shaded area. Now here you have to apply the formula. Let me tell you that formula again. Here is space, so I am writing that formula here. Integration of function, and here if there is power and derivative is multiplying there, we increase the function power by 1, n plus 1 divided by n plus 1. This is the rule. Look here, the function under the power is 4x minus 7. The derivative of this function is 4. To get 4 here, you will multiply by 4 and divide by 4 to get this form, to get this result. Now this is the function and here is the derivative. Therefore you can increase the power by 1 and divide by the same power. This is the rule. When there is a limit given, definite integral is given there, we will not write c. So solve it. 1 over 4 is outside and we will increase the power of this function by 1. So it will be 4x minus 7, 1 over 2 plus 1 is 3 over 2, divide by 3 over 2. And here apply the limit, that is 7 over 4 to 8 and plus 5. Hopefully you understand this step. We will simplify these two, 1 over 4 and 3 over 2. 1 over 4 divided by 3 over 2. You flip it and 2 will be cancelled out. For sure your answer is 1 over 6. So 1 over 6 is outside of this bracket, and here 4x minus 7. 4x minus 7 power is 3 by 2. And limit, apply the limit, that is 7 over 4 to 8 plus 5. Now we will apply the upper limit here for x. Let's see what is the result. 1 over 6, and here this 8 multiplied 4 is 32, 32 minus 7 is 25. 25 power 3 by 2. Now you plug in the lower limit, minus is of formula, then we apply a limit here. This 4 and that 4 will be cancelled out, so we left with 7 only. 7 minus 7 is 0, so whole answer will be 0 plus 5. 25 power 3 by 2 is 125, so you can solve them together. 125 divided by 6 plus 5, this is the area, and exact area will be equals to, solve these two values together, we will get the answer as 155 over 6. So this is all about question number 6. If you have any question or any doubt in this question, please write in the comment box. Thank you.